kept thinking.
It's like, my bad, Aussie. And then Chris is like, what country am I in? It's the might as well just shoot all three just in case. I do. Well, not quite.
If I don't, then I'm
It's you, Jackson's. There's a guy.
Jared, how long did you teach here for?
Yeah. Good answer. Is that your city? It's not. Even I.
I think I just need to leave them into modules. That's it.
And then after that, what the ETS
Jeff, you want some pizza?
No, not this island. No. They asked me.
I know, we're like, oh, 5
That was like listener. Yeah.
perfect time.
But then you get
That way, when we bought too much pizza, we can at least say.
doesn't go into one hundred.
Keep citing.
I'm an instructor right now.
Oh, I saw your name that said setting in the name of it, so I'm like, oh, he's got to be doing this.
Give me money.
I've been pressured very hard to start.
Don't cheap out of me, Jackson.
Whoa!
Is it Trojans? Honestly, we just need people. Honestly, that's a good point. We could have said write your name because we know the info.
Trojans would still forward to it.
True. I'm pretty sure we will never 60. Since we bought computer food, they're like, you have to prove it.
Yeah. Yeah.
We're like, it's like, okay. Well, my people, my stuff. We're like, we don't know how many people are going. They're like, okay, that's great. That's great. And then you're like, yeah, what do you think do people eat?
Yeah.
And then it's like, because the word, it's much worse to run out in our mind.
Certain most people here won't eat the same amount.
Yeah.
That's the problem. It's like, okay, there's 40 people coming.
Yeah. I need to talk to people to make sure that I can actually get into those patient sign-ups.
Get because they have like extra restrictions. Just asked us if we wanted to do it.
Apparently, they said it was going to be a little difficult for me since I got this size.
No, this is not difficult to get into. Difficult because we have to take all the classes. That was what we were wondering. It's like because we did computer science with the cyber ops back. But they just said that none of your classes will carry over.
Okay.
And that's why we're like, okay, screw
Maybe
that.
that's
I'm just gonna do
I was talking
science.
with from Keith. He said I need to talk about my opinion, talk about what would.
In all honesty, the name behind your page.
Yeah, I'm not really too worried about that. I'm just more worried about stuff I want to do.
That's true.
And
That's
Okay,
you're doing
well,
that.
seems to put that.
True. That's why you have to take so many classes.
Yeah.
There's a paper
There's
that.
a lot of people. Yeah, there's another sheet here if you want to
Sign names.
speed up.
You can sign.
Someone
find out.
We might have enough flesh not plan for these videos to make this work, or do I need to wait another year?
There were only like 3 classes that I think were it was all of like not see, they were needed, but they sunk. It was literally like when you think or well, the issue is that we were like beelined into it, which means it already had like an idea of what you wanted for your dissertation right off the rip. So it's like write chapter 1 for your dis. You know what a dissertation.
Oh yeah,
It's like okay, it was like full on. Let's see, like okay, what's my even what to do?
Yeah. Okay.
That was the only part that sucked. Like,
You just write about it. You actually want to do research on this.
yeah, that's the other issue.
Yeah. That was the one piece of advice I got. My biggest worry going into it was like, I could barely do the research at master's level. 'Cause I
Yeah.
know what I'm doing.
Writing a paper.
Writing a full dissertation sounds like 200 times worse.
It does sound
We
good.
were-
Until you start getting to that.
Yeah.
It's only bad. It also depends on your cherries because we were out on a trip and I got feedback from Mike. And Mike's like, I put comments in it. Like, again, none of them must be bad. Just bring your attention. I open up the Word document and learn comments and all this stuff. I'm like, oh. And it was so funny. There were like little words like, it's like, well, why? It's like, why do I care? And he's like, you have to answer. And I was like, oh.
Yeah.
It was fun.
Yeah. We'll see. Let you guys get underway.
Bagels like that. I got bagels and one round.
Everyone, thank you for coming tonight. If you need more pizza or haven't gotten pizza yet, feel free to come down here. Even while we're talking, feel free to get out and get some pizza. We'll do a little introduction and then we'll hop right in.
And just if you haven't signed, it's not so we're gonna do you, it's just that we need a head count for the pizza that we bought. That way we don't get in trouble. Just for that.
So today's presentation, we're gonna be talking about a project that we did at Batelle to try and give you a sense of what Batelle does for work and kind of give you some ideas on kind of cyber applications as well. But as for that, all three of us are from Batelle. Hans, I'm Logan, we have Gabby over here. Gabby's unfortunately on the slide, that's on us.
That's on us.
But me and Hans had been at DSU, we came here in 2017 and got our PhDs in 2023. So we've been here for the full gambit. We've been where you guys are sitting. The walls weren't painted when we were here though. That's the newest thing that I've noticed as soon as I walked in.
We also worked at the cyber lab on campus for 3 years.
Yeah,
before
so-
coming out to Patel.
We left DSU last year to Batelle, so you may have seen us on campus if you're an old or sophomore or higher, possibly walking around last year. Other than that, I think we'll just hop right in.
So yeah, just a quick thing too, just what we do at Patel, at least for what group Logan and I are in, we do a lot of tool development, reverse engineering, exploitation, that kind of stuff. We do have hardware groups, so people like that more. We also have like data analysts, all that stuff. So pretty much anything in the computer science field or adjacent fields, we typically do. And then, like we said, we're just gonna have a quick little overview on our project that we had worked on this previous year.
So as Hans said, we do some exploitation stuff. So today we're gonna be talking about ROP and machine learning aspect of it. So overall, we're gonna be seeing if we can integrate machine learning into ROP chain building. For those of you who don't know what ROP is, it's return-oriented programming. And I'll give you a really kind of high-level overview, but more or less, it's an exploit technique where you say you have a buffer overflow in a program and you have control of the program counter, which some of you might not understand what I'm saying already. But this is just a way to get control of a program and then jump around the code with I'm not gonna say malicious, but try and make the code do something that it wasn't intended to do through an exploit means. So here's just an example of a C program for that you might write in a class or something. This was just taken straight off online off of a CTF ROP example. But here you can see that it's just asking for your name. You read in 32 characters into name, prints it out with %s. And then it's asking you, or does the time, and then just says, what do you want me to echo out? But you can see here that we create an array that's 100 characters long, but then right after we use the read function to read in 1,000. It is insecure because we are directly saying we're going to write more data to the stack than is allowed. And then I think on the next slide, I kind of discussed the stack. So what ROP in general is saying in low level, after you compile a program down, you compile it down to assembly. And when you look at this assembly, you're going to have a lot of intricate instructions and registers you can interact with. So it's a lot of just low level stuff that actually interacts with the CPU. So in there we have something called the stack. The stack and at least x86 Intel or x86 64-bit. The stack is what's really controlling what function you're in, maybe some local variables. So that name variable would be put right here on the stack. And we could then directly overflow this name variable straight into a program counter when you say, hey, I'm done with this function, where should I go to, or where should I come back from? So what called main in this context, you can overwrite that and get control of the program. So what ROP is saying is I'm going to overwrite that with an address that I know and maybe jump around. So if we look at the top we can see an example of a pop RDI ret, pop RSI, and then pop R15 ret. Does anyone know what the importance of RDI and RSI are? Not all at once? Alright, yeah?
I mean, S is status, like for the.
Not quite. SI and DI more for index and counter. I don't think the name is as relevant because it's a back propagation from 32-bit and that comes from 16-bit. So the name isn't as important. But RDI and RSI are important because those are the registers that are used in 64-bit for the first and second argument when you call functions. So when you call a function, values will always be put into those two registers if you have multiple registers. So if we're saying, hey, I have a pop RDI ret and I have control of the stack, I now have direct control of the first argument and I can pretty much just call any function I want in a program with full control. So then we can extend that down to RSI as well. And now we have first argument, second argument, we can continue on to RDX, RCX, R8, R9, and then it just goes on the stack. But this is the whole premise of ROP, is we're saying, is there a way for us to chain these individual instructions together to get full control of a program that's not intended while being able to do something either malicious or something that we want that the program wasn't designed to do? So in this exact example, I believe that if we walk down this stack or walk up, I guess they did their stack backward, but we're going to say RSP, which is the stack pointer, is going to be starting at the address of the RDI gadget. We're popping off the value that we want. So in this case, 0x dead beef. We hit the next ret, which is the pop RSI. Yep, pop RSI. And then we're putting into that one leak beef and then leak beef into R15, which that one doesn't matter because that's just going to be a scratch register in this case. And then we're calling another function, which maybe be system, exec VE, fork, whatever you really want to get control at that point. So with this, how ROP chains are actually designed into programs is that they're not there on purpose. Intel is a CIS instruction set, so complex instruction set, I think. Yep. This means that an instruction in assembly could be variable length. So what that means is that at any index or any byte value offset into the program could be a different instruction. You could have the pop RSI R15. That's actually in the middle of a pop R14 R15. You just shift it over by 1 byte, completely different instruction. So how this works is that you can now just cycle through the entire program, look for a return instruction, walk a byte back, see what instruction's there. Is it valuable? Maybe it's not. Go back another byte, maybe a completely different instruction using all 3 bytes now. So you just keep cycling through all these to find gadgets. And there's a lot of tools out there that'll find these gadgets for you, and they're called just like Ropper, ROP gadget. Angrop is a common one. Pwn Tools is just a Python library that can let you find gadgets and build chains and just helps with Python integrations. But a lot of these tools also have capabilities to auto build chains for you. So this is saying like, hey, I want to call system with a string in this location with this payload, and it will try to build a chain for you automatically. But in this case, it will say, some of these tools have problems trying to find gadgets. So they might have limited capability where it's only looking for specific like regex. So it's saying if this exact construction exists, good. If not, I can't make this chain, and that's where the real problem lies. Angrop is slightly different because that one uses symbolic execution. Not going to get into the fine details of symbolic execution, but it's pretty much just saying, hey, let's execute this code, and what does it do without actually executing it? So it tries to assume what's going to happen, and that's the way Angrop will do, is it'll try to go through and build a bunch of assumptions saying, hey, what does this path do? What does this path do? But the difference with Angrop is that I think when we were testing it, is that off the pip install, it just doesn't work. And in the image I showed, I think this one was working, but I think it froze after about 30 minutes of just spinning. So it wasn't as useful in cases where you want something quick for a developer to be able to just work with or examine, see if something's viable. So our question is, we can do it better, right? Like, right?
So, in case you haven't heard about it, AI is kind of the hot topic right now. So basically, we were asked, hey, can you guys build ROP chains and then use AI to do it? So to give a brief example, what we need for machine learning AI is, okay, we need to define our input. So in our thing, okay, we can get ROP gadgets as our input. You need some way of scoring whatever you're doing, whether that's scoring based on a state that you get to or scoring the actions you can take. So if you think it's a good action, you'll score it higher than other actions you believe would be worse to do. And then basically you take that scoring or correctness, and then you basically present the model. Here's every action you can take, or you can hide actions depending on certain states where you're in, and say, okay, you can't even pick those no matter what their score is, irrelevant. And then obviously you have to be able to then describe the state of the system. So if we're trying to build ROP chains, what is that state? Is it ROP gadgets? Is it the state of registers? Is it the state of memory? All of that stuff. So breaking it down, like I said, we have all the gadgets we need. We should have all of our input. We just give it a ROP gadget. It should be simple enough. State, we're like, okay, is a register set? Is a register not set? Did we put something in memory? Can we read something from memory? We should be able to just say, here's your states of memory and here's your state of registers, good to go. Scoring, we didn't know exactly how to do when we first started. We're like, does it want to be how much stack we use? You know, is the exploit we're developing limited by stack? Or do we just try to want to use as little stack as possible? Or do I say, okay, I set 5 registers, that's better than setting 2 registers, or is it better than setting 1 register? A lot of questions we had to do. And then we want to decide, what is our output going to be? Is it going to be, hey, if you do this ROP chain, you'll get these gadgets, or do we want to actually try to say build a payload at the end and say convert it to a throwable exploit? Do we even want to get there at all?
So then we kind of come up with the idea of how you actually convert a gadget to input. So if you think, I'm going to just make an analogy to chess. Machine learning with chess is a common, just introductory topic, saying how do you convert that input? Well, it's obvious. You can just make the board layout, directly map it to memory, say maybe this piece is in this spot. But how do you do that with instructions? Do you look at the byte values? So all these bytes, unique instructions. But as soon as you add another byte, it's now a unique instruction again. And Intel can go up to 16 bytes of uniqueness. So that's 255 to the 16. A little too many states compared to chess. Do you just look at the mnemonics? So do you look at the actual string representation, saying pop RBX, pop RBP? Well, if you're just doing parsing on that only, now you're just making a glorified parser. So are you just making a lexicographical search saying, hey, these are the kind of instructions I want to look for? And if we look at the example, we have just in this was just from a local libc case, we had 104,000 unique gadgets or string of gadgets. So this is saying, so we need to find a way to say, hey, how do we actually convert this to something that a model can represent? And neither of these really felt like good approaches. And you just need to try and find a way to actually hone in on it. So another approach we had kind of defined is, what if we actually look at the effects? So instead of saying all these are unique gadgets, what if we just say this chain of gadgets modified RAX and just did effect base? So now we have, good, we can look at one that modified RAX, but now we have one that modified RBX. What happens when we start modifying multiple registers in single chains? Now it becomes RAX, RBX, is that a different state? Can we just keep setting more and more registers? Now we have 16 registers and it's pretty much just bitwise, so it's 16 to the second or 2 to the 16th. But what if we start doing backwards compatibility registers? So EAX, AX, AL, AH. I think that's all. Now we have 16 to the second times 5-ish. Math's off probably, but somewhere around there. Thanks. So we need to try and define like what is actually control, and is there a different way to define control? Do we say a move into a register is control? Do we say a pop from the stack into a register is control? Do we say XOR between 2 registers is control? And now we have even more states. So it's really a complex approach saying, how do you really define your input states to a machine learning project within this confined, not really confined space, but this expanding space? Huh?
Is it here with your math?
Oh, here's the math slide. Feel free to try and understand it as much as I can. So, as I said, action space becomes big, to the 16, 65,000. But then we start adding more registers, and then it just keeps growing bigger and bigger. Just too many actions to deal with. So unlike chess, where there's actually a finite number of moves in a given spot, ROP is kind of saying, hey, I have all these available moves compared to chess, 104,000 possibly. So it's really hard to define a valid input and trying to come up with a good solution for that.
So if input wasn't bad enough, we also have to say track the state of whatever the system is for the model, right? And we broke it down into basically 2 major sections. The first being, are the registers set? Are they set to specific things, or what are they set to? And then stack state and what we call raw memory state. For the register states, like we said, is it simply is a specific value in a register? Is it a value that we control? That kind of thing. Stack state, again, do we somehow control and offset it to the stack? Can we write to 14? Okay, that's more important than saying we can write to, say, 12 if we never read from 12 ever. Same thing, are there bad bytes? So can I simply not write values to the stack? So if I move a value into a register from something I control, but I know that I can never write that byte in the first place, is it really helpful to me in that state at all? And then stuff is, every time we do a gadget, a lot of these returns actually what we call clean up the stack, which means RSPs to get shifted every time we do a gadget sometimes. So if I write to 12, now when I go to the next memory state, I have to then backtrack that state and say, well, it's actually no longer RSP plus 12, it's now RSP minus some offset. Then you have to worry about collisions of states. And then raw memory state is a whole other beast, because now it's saying, can I write anywhere in memory? And while the stack has like a direct pointer to it, raw memory can basically be, can I write here? So if you go to a program, there's a whole writable, readable section, which is thousands upon thousands of bytes. And if we treat each of those individual bytes as a different state, do we just ignore it entirely? There's a lot of problems that come from the raw memory state completely. So again, some more napkin math, just to show you another explosion of problems is, we talk about register is set to a value. So we move RAX 1. So we're like, okay, RAX being set to 1 could be unique state. But then I have to say RAX being set to 2 is yet another unique state. So now if we start going to int max, we start getting, billions of possibilities just for one register. And I have, as we said, 16 registers to go through if we just talk about the full register set. So we're like, okay, that seems like a horrible idea. We'll never be able to teach the model anything because it'll never see all these states to begin with. So then we're like, okay, what if we simply say, we put a stack value into a register? We can control the stack in most cases. So we'll say, okay, a stack value is set. But then we still have the problem of, okay, it's set to a stack value, but what is that stack value, right? Because now I can write any value to the stack, so we have the same issue. So it's like, can we just abstract it and say, okay, model, you have control of it, that's good enough for us. We'll deal with this after the fact, just get me control of all the registers. And then the final thing that we had to basically deal with is, how do we even score anything? So if I'm trying to choose actions, I'm trying to score it based on the state of my system. So I see these two instructions. I can set RAX, or I can set RAX and RBX. So my question now is, are these the same score? Let's say I want to set RAX. Is there any reason to set RBX? Could be. But in a lot of trial areas, you say, okay, maybe I like setting two registers. You see what the scores are, and then your model goes off to Narnia and starts learning things you never wanted it to learn. Because if you set that second one higher, it's feel like, okay, I will always try to pick two registers, no matter what. It's like, well, that's not really what I wanted, so maybe I'll adjust the scores again. And then it's like, well, now I'll never pick the second one because I just don't want to. So this whole trial error process of, okay, well, that score was wrong, that score was wrong, I guess we can't do that. So putting it all together with all the issues, we did get a mostly working solution. It did build route chains. However, we didn't like what it actually outputted. It was slow because it had to do a lot of this processing trying to build chains. Another issue too is that as we sell, he pulled a libc version for a specific libc. So it had a defined action set. If we go to a different libc, the actions are completely different. So we had to retrain the model on an entirely different gadget set. It was somewhat random because, again, the model chooses a little bit randomly when it's first learning. So sometimes it would be pretty fast because it would go down a correct route right away. Other times it would go down the wrong route. It would have to then figure out why it was the wrong route and then come back around. And some of our early methods were just like basically tree searches to try to figure out what we could do. But whether the model was basically just an unoptimized version of what we were even trying to do. Now, what we did learn from this though is that since we had spent so much time breaking down this problem into what it actually was, throughout this process, we were able to basically design an algorithm while we were walking through it to do exactly what we wanted the model to do. And that one was much better. Unfortunately, it is proprietary, so we can't talk about it that much here. However, if you do come work for us, we can show you it and then give you a lot more details on how that model works, unfortunately. Again, where we're at, before we go, if anyone has questions, we work in the Columbus one. Gabby works at Columbus with us as well. There is one in Virginia. I believe they do try to put people in the Columbus one first. Again, you can most likely request to go to the Virginia one if you want to. I will say though, you must be even a citizen and you need to be eligible for clearance. You don't have to have one, but they will try to get you one if you do try to work with us. And then our contacts, pretty straightforward. Our last names, except for Logan, he gets an L. And then, but yeah. But yeah, if there's any questions about what we did, we'll try to answer to the best of our abilities. Or if there's just interdisciplinary what we do at Batelle, anything like that, we'll also try to answer that as well as we can do.
Otherwise, we'll also be at the career fair tomorrow if
Yep.
you want to do. I think we have more information about our internships there as well.
Yep.
Unless you want to say anything about internships
Sure.
right now?
No, they are posted on our website, so if you guys do have interest, go ahead and try to apply as soon as you can. They are up.
Yep, internships, same caveats, but you don't need a clearance for it, but you have to be clearance eligible. Other than that, if you have any questions, otherwise get more pizza. Please, we have too much apparently. Yeah.
About the pizza, can we just take a box and leave at the end?
Last ones here can do that, yeah. So now it's kind of a game of chicken, whoever stays
Whoever
longest.
stays longest.
I'll sleep here.
I don't think Tom would appreciate that.
Just gotta get here before Tom gets here.
True, Tom's.
Yeah.
Any other questions? Otherwise, thank you. Oh, yeah?
When you guys are like building the ROP chains, I saw earlier in one of the example pictures you had, there were some NBR 64 instructions in
Yes.
there.
Yes.
Do those like throw wrench in all of that like super
Not
significantly?
Particularly, NBR 64, for those who don't know, is a forward-looking, CQ specific protection for, oh my gosh, I feel like I should know this acronym since it's about my dissertation.
I don't know what it
It's
says.
the JOP prevention in Intel. So it's just saying that you have to end a jump at this location, but not a return. So those don't really do anything. In this case, they're mostly just knobs.
Okay.
So they won't actually affect that much.
That makes sense.
Thank you for coming. Grab some pizza, play chicken with each other. We'll technically have to be here just as long then. So that's cool. Oh, yes.
If you were gonna cop out in the end and not tell us the solution anyway, why didn't you just say it was perfect? You said it
Well,
worked
that would-
better.
that
You
would
could
make
just
us
say it's
feel bad,
perfect, 'cause
because-
you're not gonna tell us how. it
I don't
works.
wanna lie to you.
Because I know if I said it was perfect, you would have just called it right away.
Tease us the whole presentation.
I think if we
You
scroll
could
back to the
lie
front,
at the end.
what was the first slide?
It was,
Solving problems through failure.
yeah.
So,
Well, and if I went to work there, found out that it wasn't perfect.
Yeah, what would
I don't know that I want to keep working.
Could you tell me and then
They're
me
on it,
comment on it?
honestly, if he came and worked here, then yeah, he could tell you. I won't stop him from telling you. He shouldn't, but
It's posted online. I'm sure they love that.
Yeah, I would tell you more, but you know just how much we have to worry about export controls as much as the next guy. So
I will say we had
more details.
we had more details, and then our boss said no.
Yeah, he basically called us to the office and like, hey, can you guys come talk to me for 30 minutes? Can you give me a verbal walkthrough of your slide deck so I can verify you can say anything you're about to say? And it's like,
We
Sure.
were approved for this slide deck yesterday.
yes,
so
that is another catch too.
plenty of lead.
We're asking our project manager, hey, do you ever get approved? And they're like, nope.
Yeah.
It's like, oh.
I'm just curious, did you find any like, I'm not sure how you're testing this, but did you find any like different ways that a bino is compiled and different like gadgets found? Was there some like observations, like if someone was compiled like
We did not
was
do.
there certain like chains like go certain ways to compile or things that would make
Yeah. For this project, we did not do any analysis into the types of compilation gadgets. That just wasn't a part of this research agenda at the moment. But I'm fairly certain that does happen, yeah.
We pretty much just said, we pull libc up, we're like, what gadgets do we have? That's what we got. And then, so like, if it changed, we wouldn't really know if it was compiled differently. We were simply saying, oh, we either have less gadgets or this is our gadget pool for this binary.
Okay.
Yeah, for those who, we said libc a lot, for those that don't know, libc is a basic library that is loaded in pretty much every running Linux binary.
So is the is the machine learning algorithm that you guys use for AI, is that one, would that, because of the way you trained it, would that be specific to x86 64 processors? Or would you be able to adapt it or would it be able to like work with other architects?
It really came down to the training test set and what it was targeted for, but yes, it was very hard to make something super generalized.
And also, would it benefit at all from something like symbolic execution?
So the problem with symbolic execution is you run into the branch explosion problem, is if you have any conditional jumps or conditional sets, which way did it go? What current value is in that register?
Okay.
So that's really the problem. It would, I think, actually help, but it's hard to quantify that in a state of where am I? Whereas if you try to just ignore those, then you don't really need conditional or symbolic execution because you have a good idea of what's in the register.
In simpler terms for everyone else, he's basically saying in like C you have if else's. Assembly also has basically if else's inside of it. So when you hit an if else block in your ROP chain and it's based on a previous register state, you have to choose a path or attempt to choose both paths. And then every time you choose a path, you're now timed it by 2 over and over and over again. That's what the whole branch explosion problem is, and why symbolic execution has problems. Why we saw Angrop basically freezing, is that it hit so many conditional paths. It eventually kept trying to evaluate them over and over and over again. You can actually get stuck in a loop sometimes as well, and then you would have to detect you're even in a loop to begin with.
Yeah.
And also with the loop detection, aren't there algorithms for graphs that you could be able like this check if you are in a like
Cyclic. Yeah, there definitely is, but there's also the case of what if you actually want to be in that loop? Like how many times do you want to be in that loop? It's like the more you keep adding, the more edge cases you kind of run into, so it's really hard to say, where do I actually draw the line?
Okay.
Like if you want to get a value, say 10 in a register, why not just go for your loop 10 times and increment register by 1? You just call it increment rex ret, and then have some way of breaking out. And it's like, okay, this is good enough for me. That's what I want it to be. So it's like, do I say you can loop 10 times and you break? Right? It's like you said, there's edge case upon edge case of how do we have to, you try something, you're like, this didn't work at all. And you're like, why didn't it work? And then you have to figure out why it didn't work and then try to address it. And then you get different edge cases. There was like this continuous building problem until it finally like, okay, we've solved enough edge cases where it just works. It's like, if we hit an edge case, whatever, we can still find a route somewhere.
Yeah.
Is there any difference for you guys between two ROP chains that both achieve the function you want to achieve? One that kind of short and elegant, one that's really long and that kind of winds to get there, but eventually gets there in the end?
Depends on whatever your needs are.
Yeah.
Like that goes back to the scoring problem is like, how do you score it? Do you just need it to work? Then no, I don't care. Give me a chain that works. There'd have to be some other defined metric saying, there'd have to be a reason for you to care.
Yeah.
Yeah.
Can you change metrics on the fly? Like,
Change metrics on the fly.
if you wanted something that scored better for elegance,
Yeah.
everything else in the company, you wanted something that, and it didn't matter how long it took to get there.
For the machine learning one, I want to say yes.
Or
Because we did have scores. It would score it. That one, yes. The
It really
algorithm
come
one
down
would
to
be harder.
how you define the scoring, I would say.
Because the algorithm one, we did like define things. Like those, like we hard coded things, say like we want these.
Yeah.
That one would not be malleable. But we thought that one was effective enough where we designed it in a way where it shouldn't need to be changed in our mind. But there's a chance it does.
Maybe you should come back and come check it out.
Yeah, this one's, let's say in your first binary that you're training.
Yep.
You have access to non-randomized function calls, so RDI, RSI, RDX matter. But then in another binary, syscalls seem to be more important. So you could ret to a non-randomized syscall. Now RAX matters.
Yep.
And RDX, RDI, RSI. What would it do? And this is kind of similar to Tristan's question, but how would you change metrics if you hit a binary with no non-randomized function calls, but you do have syscalls?
Yeah.
So
How do we want to answer this?
you can say what the month alpha too. I can say
Um,
we said we could, right?
You have to work there, Jared.
then you might have to work.
Yeah, give it. We have to deliver for like half of this.
If you actually want to know,
So yeah,
I can
that's
email you after we get.
yeah. So this
like,
this
told
becomes
we
a
could say
thing where we don't know. There's things we don't know if we can or can't say. That's a email us kind of question. We will like verify that we can say it and then give you a much more like as accurate as we could possibly get kind of answer to it, because at some point we're getting really close to the how we solve some of these problems, which
Are
is
you just saying it because it's me? If someone else asked.
no,
would you answer?
no, this is not you. This is a full. I do not know if I can actually answer your question the way I want to,
That's okay. That makes it good questions.
because now we're gonna get more into the interworkings of how this stuff, our the tool that we wrote at switch was the big no-no.
What classes do you teach here at UC?
I taught a binary exploitation class, just as an extracurricular in 22,
22, I think.
22 spring, I think.
It was around there. I simply taught CSE 150.
So you answered my question earlier about it being for like government contracts,
Yeah.
well, what most of your company does, but does the certain like algorithms and stuff, do they eventually like go out in the market or do they stay sealed?
These ones are probably most likely proprietary.
Yeah, so they'll be in-house. So like anyone in say like our unit or like adjacent units could be like, hey, I have this problem. Can you guys look at it? We're like, sure. We'll just pull up our tool database and try to see what we can do. But no, unless the client says like, hey, we want to release this, it'll either go straight to the client or it'll stay in-house, or potentially both.
Can you guys talk a little bit to like your section of work at Batelle? So like you guys are definitely in national security, but like, can you kind of talk to like some of the different areas that they might be interested or have like interest in? Maybe like a high, like overview if possible.
Should be able to. We're just a part of the cyber group pretty much. Like Hans had said, our group in particular is a lot about tooling and reverse engineering. I know another group is more into the data analysis, if that's up your alley. And what was the third?
Hardware.
Hardware's a big one.
Yeah, basically the vision that Logan and I are in are basically we have problems that are either trying to be solved or are already solved. And it's basically our job to basically say, okay, we're spending basically man hours on these problems. Can you guys make it so we don't have to spend man hours on these problems? Is basically what we've mainly been doing.
Or reverse engineer this, what's it doing, that kind of stuff. Yeah, a lot of low level applications.
No, that's good. I just kind of wanted to give them give them a feel of what Battelle is working on in the sector.
I will say though, if you're in cyber ops, right? Assembly language, super important, and operating system, also really important classes here. Really, really pay attention to those classes. They will help you. They will come up a lot more often than you would think, especially operating systems.
Actually, does our past summer intern want to say anything about their internship?
Really good. Unfortunately, I didn't get a chance to work very closely with you guys. I was hoping to, but it's definitely a fun place to work. There's some neat projects that are done. If you're in cybersecurity and what the systems work, I know a lot of people immediately shoot for pen testing. I kind of find pen testing to be repetitive and redundant, and so going to work at a research company provides consistently cool work. There's always a new problem. There's always something new to be solved. Yeah.
Thank you.
Yeah. Location based.
So our main base is in Columbus, Ohio. That's where our main hub is. Our cyber division has another branch office in Chantilly, Virginia. Right now, I do not think we offer remote work. I think there's a way to get it someplace in Hawaii. I don't know the details about that one.
It also depends on what group you're in.
Yeah.
Because our group is heavily, you don't get much remote work at all if you do.
Mhm.
And then some of the other divisions might, I'm not entirely sure on what they can or cannot
Just due to
do.
the nature of the work, it's very in-house.
They do try to keep a lot of stuff closer to the chest, and it's harder to do that when people are remote fully. Not to say that we can.
Mhm.
It's just that it's sometimes rare. I think there is another one in Beaver Creek. I don't know who goes there though. That's where I originally thought we were going. There's technically more, but for like cyber
Yeah,
stuff.
so this is
these
all
are-
the
these are
cyber
gonna
stuff.
be
If
your
you're
two.
interested in maybe, Batelle also does a lot of biochemistry stuff.
Yep.
So if you want to do cyber analysis within biochemistry. They also do a lot of that. They also do a lot of chemicals and stuff.
Cause I think there is
I'm trying to think of what they all.
There,
they do
there,
a lot
there
of
is
stuff.
overlap with say like if you want to be on the data analyst side, I'm pretty sure there's a decent chunk of overlap between data analyst and like the medical bio stuff, where they're basically saying, okay, is there any way we can help do any analysis on your medical data?
So maybe if you want to do cyber adjacent, but still like want to get hands on like chemistry or biology, science.
They have raw engineering as well,
Yeah.
but I'm not really sure we're known for our engineering here at DSU. Do we have engineering degrees? I actually don't even know. I don't think we do. I was gonna say, I don't think we did, but I didn't want to say we didn't.
All right, thank you all again. I think that's everyone. If you have any other questions that you don't want to say out loud, we'll be here for a bit. Otherwise, thank you all for coming and hope to see you tomorrow at our booth. Yeah, grab some pizza on your way out, and then